understanding how molecular collision rate scales with temperature and volume. So let's look at those two things separately, okay? So obviously, if you increase the temperature, you're increasing the kinetic energy of whatever your gas is. If you're increasing the kinetic energy, you're going to increase the collision rate, okay? So anytime we see an increase in temperature, we should see that is going to correspond directly to an increase in kinetic energy and an increase in collision rate. Okay, so let's talk about pressure. Okay, if you increase the pressure, then your particles are moving around faster, so you're going to increase the collision rate as well if you increase the pressure. So what is the relationship between pressure and volume? Oops, I didn't mean to do that. Well, if you have a smaller volume, you're going to have a higher pressure because you're squeezing the particles into a smaller area. So a decrease in volume is going to result in an increase in collision rate and vice versa. If you go to a larger volume, then the particles have got more space to move around in, so they're not going to collide as often. So you've got to kind of just look at what you got and see if you can tease out. So here I see I've got two identical volumes. These are the smallest volumes, so they should have the highest pressure out of all these. So these are going to have a nice high collision rate, and we've got two different temperatures, okay? Minus 32 is hotter than minus 59, okay? So this one is going to have the most collisions out of what I can see here. So I would give that the 1, okay? Because out of those two temperatures, this is the hotter one, okay? So same volume, and the smaller volume means more pressure, therefore higher collision rate. Okay, and then this one has to be number 2. So what else have we got next? Again, we have the same temperature for the other two, but different volumes. Okay, so a smaller volume is going to be a higher pressure, more collision rate. So 32 would be a smaller volume than 36. So that has to be my next. And then this one would be last. Okay, so this 4 is the least amount of collisions per second, and 1 would be the most amount of collisions per second. Okay, so I'm going to show you another one, just so you can see the kind of variation. So again, it's like picking out what is the same, what is different. Okay, let's see if I can get rid of those. Okay, so looking at these, I've got 2 where I've got the same temperature, which is these ones, and these 2 have the same temperature as well, and then I've got 2 with the same volume here. Okay, so what is going to have the smallest volume would be this one, and that's also at the highest temperature. Look, so the smallest volume and the highest temperatures, that should have the most collisions. Okay, and then out of all there's only 121 liters, so then my next highest pressure will be at 24 liters, and we've got 2 different temperatures, minus 70, minus 30. Minus 39 is hotter than minus 70, believe it or not. So that would be my second, and then this one would be my third. And then my least collisions would be my largest volume, which is going to have the lowest pressure and at the lowest temperature. So that is going to be the least amount of collisions per second. Okay, so hopefully that's helpful for you guys.